Hello ladies and gentlemen, this is Infinity Math, and what I have prepared for you is an algebra problem which kind of looks like this. So we have to solve this sum here that is a sum of fractions that the denominator is also a sum of integers. But before I get started on this video, I want to remind you to leave a like and a comment and subscribe to my channel if you haven't already. And without further ado, let's get right into this problem. So the first thing that I want to do is remind you the Gauss formula for summation, which will certainly help us because once again, let's look at the denominators and notice that each of them is the sum of few positive integers. So anyway, in case you didn't know this formula, I make sure to post a video soon in which I'll maybe cover up a proof for it. Anyway, I want to use this formula to write each denominator as a product, namely n times n plus 1 over 2. But let's be honest with this, nobody likes working with nested fractions, so I'm going to take the denominator and flip it so that the 2 over there gets out the denominator. And thus it can be easily factored out into the front of this sum. And now we have to use a little trick to evaluate each term of this sum. So what I want to do is I want to look at each fraction of type 1 over n times n plus 1. And we have to decompose it into partial fractions. But in case you're not familiar with that, there is a simpler thing to do. So we can just look at the numerator and then add and subtract an n. And we get something like this. But well, of course, you may wonder, why did we do that? So the thing is that we can actually split this fraction into two fractions, and the result looks something like this. So at first sight, it seems a bit more complicated, but then we can immediately notice that some terms cancel out. So in the first fraction, the n plus 1 cancels out, and in the same manner, the n cancels out in the second fraction. And what we obtain is actually a difference of fractions, namely 1 over n minus 1 over n plus 1. So, to recap a bit, we have obtained that 1 over n times n plus 1 is equal to 1 over n minus 1 over n plus 1. So, let's head back a bit. Where did this start from? So, we had a sum which is 1 over 1 plus 1 over 1 plus 2 plus 1 over 1 plus 2 plus 3 and so on. And we use the Gauss formula to determine that this is equal to 2 times 1 over 1 times 2 plus 1 over 2 times 3 and so on. And we will actually use the fact that we prove right now to see that this is in fact a sum of much simpler fractions, which looks something like this. And I think now it becomes clear why we did all that. So we can see that a lot of terms cancels out, like minus 1 over 2 plus 1 over 2, minus 1 over 3 plus 1 over 3, and all the way up to minus 1 over 100 plus 1 over 100. So basically, like almost all of the terms cancels out. And we would only remain with the first one, which is 1 over 1 minus 1 over 101, which is the last term. And we only get two terms. And this sort of sums in which we can just cancel out a lot of terms and end up with something really small is called a telescopic sum for, well, an obvious reason. It's good to note that. Okay, so all that's left to do now is amplify the first term so that we would get 101 minus 1 over 101. And this would just result to be 100 over 101, and multiplying it with the 2 in the front would result in 200 over 101. So this turns out to be the final result of this really nice problem, and I think it gave us a really simple result for how complicated it looked in the beginning. And maybe it's also good to know that this problem can be generalized to an arbitrarily n number, so we can have the final sum can be up to n, and I'll leave that up to you. Maybe you can write an answer down in the comments to see a general result for this problem. But anyway, if you enjoyed this problem, I would really appreciate you subscribe to my channel and leave a like and a comment if you enjoyed this type of videos. Goodbye and see you on the next time.